So till now we have seen what is arithmetic progression, how to find the nth term of an arithmetic progression. So and we have also seen some of the example of finding the nth term of an arithmetic progression. So let's take one more example of the nth term of an AP. So let's say if m term of an AP be 1 by n and nth term of an AP be 1 by m, then show that the mth term of the same AP is 1. So it means it is given that mth term of some AP is 1 by m and nth term is 1 by n. So we have to show the mth term of the same AP is 1. So how to solve it? As we have seen the formula for finding the nth term of an AP. So what was the formula? It is an is equal to a plus n minus 1 into d. So as it is given the mth term of an AP, so in place of n we'll take it as m. So mth term will become a plus m minus 1 into d, which is equal to 1 by n. So this is the first equation, and in the same way it is given that nth term of an AP is 1 by m. So a nth term is a plus n minus 1 into d is equal to 1 by m, which is the second equation. So now we have to solve this two equations, and we have to find out the value of a and d, because we have to prove that the mth term of an AP is equal to 1. So if we take the mth term of an AP, it is equal to a mn is equal to a plus mn minus 1 into d. So as we see that we have to find out the value of a and d, and we have to keep the value of a and d in this equation, so we can find out the value of mth term. So there were two equations that we have already seen. First equation is a plus m minus 1 d is equal to 1 by n, and a plus n minus 1 d is equal to 1 by n. So now we will subtract these two equations. So subtract second from 1. So we are subtracting the second equation from the 1, or you can also subtract the first equation from the second. Anyway, in any case you can get the same result. So we are subtracting the second equation from the first. So what we will get is, the first equation was a plus m minus 1 and m minus 1 d is equal to 1 by n. So that will become 1 by n minus 1 by m is equal to a plus m minus 1 into d minus of a plus n minus 1 into d. So when we subtract the second equation from the first, we will get this. So now we have to solve this thing, and we have to find the value of a and d. So when we solve it, what we will get is m minus n upon mn is equal to a plus m into d minus d minus a minus n into d and plus d. So as we see in this equation that there are two terms which are same but of the opposite sign. So there is a which is of opposite sign. One is of positive and one is of negative sign. In the same equation there is d which is of opposite sign. One is positive, one is negative. So we'll cancel those terms, and what the remaining term we will get is m minus n upon mn is equal to d into m minus n. So as we see that m minus n is the common part in this equation, so we can cancel this mn minus n part, and after cancelling it, the value of d what we'll get is d is equal to 1 by mn. So this is the common value of common difference that we have got, which is equal to 1 by mn. So in the same way, the value of d as we have got, so we have to keep the value of d in any of these equations. Let's say we can keep the value of d in the first equation. So when we keep the value of d in the first equation, we have to find out the value of a from that. So the value of d in the, so what was the first equation? First equation was a plus m minus 1 d is equal to 1 by n. So as we keep the value of d in this equation, what we'll get is a plus m minus 1 d is 1 by mn, which is equal to 1 by n. So after further solving it, we'll get is a is equal to, we will take this m minus 1 into 1 by mn part on the other side of the equation, because we have to find out the value of a. So will become a is equal to 1 by n minus m minus 1 upon mn. So as we remove the bracket part, what we'll get is a 1 by n minus 1 by n plus 1 by mn. So 1 minus, as n is common and both are of opposite sign, so we'll cancel those part. So we'll get the value of a, which is equal to 1 by mn, and which is also equal to the value of the common difference, that is equal to 1 by mn. So now we'll keep the value of a and d in the mnth term of the same AP. So mnth term of the same AP was a plus mn minus 1 into d. As we see, the value of a is 1 by mn. So we'll keep the value of a in this equation. So 1 by mn plus mn minus 1 into d. So value of d was also 1 by mn. So we have kept the value of a and d in this equation. Now we have to solve this equation. So it is 1 by mn plus, as we remove the bracket part, what we'll get is mn by mn minus 1 by mn. So as we are seeing that 1 by mn is the common part but of the opposite side. So we can cancel this part. So what we'll get is a of mn is equal to mn upon mn. So we can cancel m from m and n from s so after cancelling it, what we'll get is equal to 1. So the value of a mn will got is 1, which actually we have to prove. So in this way, we have seen that while using the formula for finding the nth term of an AP, we have calculated the value of mnth term of an AP, which is equal to 1.